In this lesson we're going to look at how we can graph more complex logarithmic functions. In a previous lesson we looked at how you graph a log function by rewriting it as an exponential function, and then because we switch x and y and to find inverses, and exponential functions are inverses of logs, we're able to use that table as a way of solving the log. If you haven't looked at that lesson, you might go back and review graphing logarithms first and then come to this one. This will be the same technique we're going to use here. Before we can really rewrite this logarithm as an exponential function, we need to isolate the log with its base and its argument. So there's a 2 in this equation that we don't need to be on the side with the log, so we're going to subtract it from both sides to get rid of it on the right side of this equation. And that will leave this. Now I have a log base 3 and an argument of x minus 1. So now I'm ready to rewrite this in exponential form. My base, which is 3, my exponent, which is everything on the opposite side of the equal sign from log, in this case y minus 2, and it's equal to the argument, which is the part in parentheses after the log, x minus 1 in this case. Now I'm almost ready to make a table, except that I need the x by itself. So I'm going to go ahead and add 1 to both sides. 3 to the y minus 2 plus 1. Be sure you don't put that plus 1 up there with the exponents. It is down there with the base, so don't add it to the exponent by mistake. Now we're ready to make a table of values here. I'll make myself an xy table over here. And I'm going to start my table just because I kind of know where they're going to be, but you could experiment if you needed to with 1. And I'll go to 5 here and see how that looks. When I plug 1 in here, 3 to the 1 minus 2 is 3 to the negative 1 power, which means 1 over 3, or 1/3. When I add 1/3 to 1, we get 1.333, just repeating. Like that. And when I put 2 in for y, 2 minus 2 is 0. Anything to the 0 power is 1. So 1 plus 1 is 2. When I plug 3 into my table, 3 minus 2 is 1. 3 to the first power is 3, plus 1 is 4. When I plug 4 in, 4 minus 2 is 2. 3 squared is 9, plus 1 is 10. I can already see it's getting pretty big for my graph. And finally, when I plug 5 in, 3 to the third power is 27, plus 1 is 28. Way bigger than I'm going to be able to use on my sketch here. So let's graph this. And I'm going to just go ahead and erase that 28 and 5. I'm not going to need those. Okay, so there's 1, 2, 3, 4, about all I'm going to get in. And I notice that when x is 1.33, that y is 1. So 1 1/3 and up 1. Something like that. Also 2 and 2, 4 and 3. And I know from my knowledge here of logarithms, or should know, logarithms approach a number here that is an asymptote, and in this case our asymptote, our vertical asymptote, is at 1. It's going to come up like this and head off that way to infinity and down this way to infinity, never really touching the vertical asymptote at 1, but approaching it infinitely close. And there would then be the graph of y equals 2 plus log base 3 of x minus 1.